Okay, guys, sorry about having to do the video with all the snow days this year, but don't forget when you come back on Friday, we'll have formative on Friday covering 7.1 through 7.3. So just to get at it, a lot of people won't have to watch this whole video. I think most people have the general concept over the first couple examples. However, I'm going to do all of them. Feel free to stop, pause, rewind, fast forward, whatever you want to do. And after I'm done with each problem after the warm-up, I will show the actual graphing calculator version of it, and we'll go from there. So Tuesday, we found out to determine the horizontal asymptote of a rational function, where the degree of the numerator is the same as the degree of the numerator, we divide the lead coefficients. So that means the horizontal asymptote will be y equals the lead coefficient of the numerator. And remember, that's the number on the biggest power of x in the top divided by the lead coefficient of the denominator. And remember, that's the biggest coefficient on the largest power of x in the denominator. And one great sketching aid here, the value that results in the numerator of a rational function equal to 0, which are zeros of the numerator. Those are x-intercepts, so there's something, comma 0, showing that they are on the x-axis. So as we go through this first warm-up problem, you can give it a shot here quick. First thing I would personally do when I do this is I would factor the numerator out, and I would see there's a -2 I can pull out of there. You don't have to do this. It makes it easier for me. And then I'd be looking at 3x plus 1 over the quantity 2x plus 1. Now, as I go through these things, I usually do things a little bit different. I like to find my vertical asymptote first. Vertical asymptotes are the zeros of the denominator, so I would take that whole expression, 2x plus 1, set it equal to 0. I would solve that equation for 0 to find out x equals -1/2, and my vertical asymptote is x equals -1/2. I would then graph that little bugger on my graph as best I could, trying to get it relatively in the spot to where it needs to be. And if I can grab it, it's not letting me grab it. There we go. Get it about to 1/2. And after that, I would automatically go to my horizontal asymptotes. And my horizontal asymptotes are going to be y equals the lead coefficient of the numerator, which is going to be -6, divided by the coefficient in the denominator, which is 2. That'll give me a horizontal asymptote of -3. I would then graph that horizontal asymptote of y equals -3. Those are great sketching aids to first put on there. Next, after that, the second easiest thing to do would be to find the y-intercept. That is, plug a 0 in for all x's, which means I can see after I do that, I'm going to have 0, comma, something, and when I plug 0 into the numerator, I'm going to end up with -2 over 1. So that's going to be 0, comma, -2, and I would plot my y-intercept as best I possibly can. And then the x-intercepts are the final thing I find. These are a huge piece of information when you're graphing rational functions. Those are set the numerator factors equal to 0. So that's going to be something, comma 0, because they are on the x-intercept or the x-axis, and I would take my expression on the numerator that has an x with it. I'd take my 3x plus 1. I would set it equal to 0 to find out 3x equals -1, to find out x equals -1/3. So that would be -1/3, comma 0. And I would plot that, and it's real close to my vertical asymptote here. It's not quite on it. Now I say that that's a big piece of information because this is the only time I will ever touch the x-axis. So I know that my graph is going to be coming across my horizontal asymptote. It's going to turn up, and it's going to go straight up that side. And I also do know that my branch is going to be down here in this area, down in the quadrant 4 area, below the horizontal asymptote. And if you do not understand why, all you're going to do is you're going to plot a couple additional points. And what I would do is I would pick a point to the left of my vertical asymptote, say -1, And I would plug that -1 into my original function up here, and I would find out it's going to squirt out -4. So I'd plot out -1, -4, and then I can see that that branch is underneath the x-axis, and it's going to go straight down, and they graph relatively simply. And if you understand what I'm talking about the x-intercept being the only time you're across the x-axis, it has to be below that horizontal asymptote. Otherwise, when it hits that vertical asymptote, if it were on top, it would have to go up. Hence, it would cross the x-axis again. And we do not have that happening more than one time. So, number 2, first thing I would do is I would factor my rational function. And we will find out probably on Monday why we always want to factor things first. Sometimes our expression will reduce, and when it reduces, something special happens in the graph. And when I look at this, I see it does not reduce in any way, shape, or form. And first thing I would do is find my vertical asymptotes. And I can see there are 2 of them in this one, when x equals 4 and when x equals -3. So the next thing I would do is I would plot my vertical asymptotes here at 4 and -3. And after I did that, I am going to take a little gander at my horizontal asymptotes. I can see the degree of the numerator is 2, the degree of the denominator is 2, so the horizontal asymptote will be lead coefficient over lead coefficient, or y equals 1. I will plot that horizontal asymptote at y equals 1. And after I plotted my asymptotes, next thing I would do is I would find my y-intercept. Because when I plug 0 in for x, I can see anything with an x is going to be gone, and I end up with 0, 1/2. And my y-intercept, I can see that is going to be 0, +1/2 right up into this area. And my x-intercepts are going to be zeros of the numerator, where I can see one of them is going to be 3, 0, because if I plug 3 into this, I'll get 0 on the top. And if I plug -2 into that factor, I would get 0. So I have 2 x-intercepts, one at 3, 0, and one at -2, 0. And I know as I pick points closer to my vertical asymptotes, I do know that the behavior of my graph is either going to go straight up or it's going to go straight down. So this whole middle section, I can tell I can only cross the x-axis in these 2 places where these 2 dots are, so I know this one's going to kind of come down and follow my asymptote. This other one's also going to come down and follow my asymptote. Now, I also know that my branches on the outsides of both of these vertical asymptotes to the right side of my x equals 4, it has to be up here because I am not going to cross that x-axis again. And it has to be up here for this side, again, because I'm not going to cross the x-axis. We are not after perfect graphs with these rational functions. We are after the general shape and where they generally belong. And if you don't understand why I said they're up in those 2 spots, what you would do is you would find a point on the left and a point on the right of each one of those asymptotes, meaning I would plug in 1, 2, 3, 4, 5 for x to find out where the branch is on this side here. And I would plug in 1, 2, 3, -4 to find out where it is on this side. And after I substitute those 2 values in, I would have my y values. I'm not going to waste my time to do it right now. But if you did, you'll see my graph branches might be plotted off a little bit, but they are in the right spot where they belong. And if I double check this on my graphing calculator, I see that that is where my asymptotes belong. I can see that that's exactly where everything needs to be for me on this problem. And I will shut that graph down, hopefully. And I will move on to the next problem. And again, first thing I'm going to do is what we just did on our warm-up problem here. So I'm going to skip this one now that I see that that is I believe, the exact same problem. That is the exact same problem we did in the warm-up. So this was the warm-up problem. And it is done. So we are going to skip right on to the next one. Okay, now this is just talking again. Well, what if the degree of the numerator is bigger than the degree of the denominator? Okay, denominator is bigger than numerator. This is going to change how we find our horizontal asymptote. Actually, in the first couple sections, that's what we did. When the numerator was a constant, the numerator was smaller than the denominator, and we found out that it is always at y equals 0 when this happens. So what I would first do on my function here is I would factor that little bugger, and it's going to end up being 4x over, let's see, I'm going to have two parentheses, I'm going to have a 2x and an x, and I'm going to have a plus 3 and a minus 1. And as I can see, nothing will reduce out. So what I like to find first are my vertical asymptotes. They are the easiest for me. I can see I have one at x equals 1/2. That is at 0 of the denominator. And I have one at x equals -3. That's at that 0 of the denominator. Then when I'm looking, not my y-intercept, I'm looking for my horizontal asymptote, I can see the degree of the numerator is smaller than the degree of the denominator. And this is a rule, one of the rules we're going to have. If the degree of the numerator is less than the degree of the denominator, our horizontal asymptote will always be at y equals 2, or y equals 0, excuse me. So I'm going to have this, and I'm just going to go ahead, plot these three little asymptotes quick. So I got one here at -3, I got one at 1/2, and I have my horizontal at y equals 0. And of course, I missed the mark on all of them, so I'm going to try to get them about where they go. And whoop, I'm just going to move the whole thing. And it looks like I got them pretty close. So after that, then I will find my x-intercepts. I apologize. Those are zeros of the numerator. That's right here. What makes that numerator 0 is when I put a 0 in for x, I get a 0 out for y. It's a 0, 0. Again, to find that, I just take 4x, I set it equal to 0 to find out x equals 0. So I do have one right there. My y-intercept, well, that's where I come back. That's a 0, something. This, you don't have to think a lot about that. I would always come back to the original equation over here. Anything that has an x with it is a 0. So that's a 0, that's a 0, and I end up getting 0 over -3. Well, 0 divided by anything is 0. Big shocker. If I have a point at the origin, it's both my x and y-intercept. And remember, we can never have more than one y-intercept in any function. Now, this is a crafty little critter here. So because this one, I can't tell what's going on, what's going to happen is I'm going to have to find a couple additional points here. I'm going to have to plug a couple x's in, a couple y's, and what I want to do is I want to find something on the far right side. So what I'm going to do is I'm going to plug in a +1 to find that. I'm going to want to find out what's going way over on the left side, so I'm going to plug in a -4 as well. Or I could even go out to 5. It really doesn't matter over there. But when I plug 1 into my original equation up here, what I'm going to have in my factored form, I'm going to have 4 times, put a 1 in there, I'm going to have 1 times 4. So I can see I'm going to have 4 over 4. So that's going to be 1, 1. And that one's going to go right there, which tells me, because I can't cross the x-axis again, that again tells me my branch is going to be here, and it's going to swoop down this side. It's going to stay on top. And also, when I come out here at -4, well, that's going to give me -16 over, but a -4 times 2 is -8, so that's going to give me a -9. It's a bad 9. And when I put negative 4 in this second one, I get a negative 1, which is going to give me negative 16 over 9. Again, mainly the thing I'm looking at here is this is going to be negative 16 over 9. So when I come over 4, I'm going to be somewhere in the negative. Well, 16 over 9, that's almost 2. That's going to put us somewhere right over into here. And my graph is going to be in these two areas here. And the only other thing I need to know is what's going on here in the middle. Well, in order to figure that out, I'm going to have to maybe plug a negative 1 in there to find out what is going to be happening on the left side of my x-intercept. Well, when I plug a negative 1 in there, I can see up there in the top, when I plug negative 4 times negative 1 is negative 4. And that's going to be divided by 2 times negative 1 is negative 2, so that gives me a negative 3. And when I plug negative 1 plus 3 is going to give me 2. So that's going to give me negative 4 over negative 6, which is positive 2/3. So because that's a positive number, when I come over to a negative, I'm going to come up 2/3. Well, I can see this is now going to be coming up on me like that. And that graph is either going to bounce and go up on the side of that asymptote, or it's going to go down. So I'm going to have fun here, and I'm going to have to try to plug in positive 1/3. And what that's going to give me positive 4 over 3 over, when I plug 1/3, that's 2/3 minus 1/3. That gives me negative 1/3. And that's going to multiply by 1/3 plus, that's 3 1/3, 3 1/3. And what I see is my numerator is going to be a positive number. My denominator is going to be a negative, because a negative times a positive is a negative. So I know I'm going to have 1/3 comma some negative number, which tells me I am going down my asymptote. And let's take a little look at this one on the graph. We're going to squirrel that over, and that's not the one I want. That's the one I want right there. And I can see that my graph that we did generally looks like that one as well. And let's minimize that little bugger off of there. Get that dumb mark. Then next thing we're going to do is we are going to jump over to number 4. Number 4, again, anytime the degree of the numerator is less than the degree of the denominator, the horizontal asymptote will always be y equals 0. So first thing I'm going to do here is I'm going to look at number 4, and I'm going to say that's x plus 2. I'm going to factor my denominator, which is going to be an x and a plus 4 and a minus 2 to get a plus 2 in there. I see nothing will reduce between numerator and denominator. First thing I like to do is my vertical asymptotes. I can see I have one at x equals negative 4, and I can see I have one at x equals 2. My horizontal asymptote is going to be y equals 0, because the degree of the numerator is 1, the degree of the denominator is 2. Numerator is less than the denominator, therefore it's always at y equals 0. I will plot these asymptotes quick, and I got 1, 2, 3, 1 at negative 4. I got one at 2. They're off a little bit, and I got one at y equals 0. I will try to grab with my pointer, get them on where they belong roughly, and it's not, that's good enough. From there, I always find look at what's easiest. Well, it's a horse apiece. The y-intercept is always 0 comma something, and I always like to go back to the original unfactored problem, because when I plug 0 in, I'm like, you're gone, you're gone, you're gone. And I end up with 2 over negative 8. Well, that's negative 1/4. So I can plot that. I can see it's just a hint underneath the x-axis. Is somewhere right down in here. And my x-intercepts, well, those are zeros of the numerator. So what I do is I just take that numerator, x plus 2, set it equal to 0. I find out x equals negative 2. So my x-intercepts are at negative 2, comma 0, because whenever the numerator of a fraction equals 0, the y will always be 0. So I can see here I'm at negative 2, comma 0, and I can see I'm going to be crossing this asymptote possibly in the middle here. So I do need some additional points again, so I'm going to have to take an x, a y. I like to find the far right first, so I would plug a 3 in for that far right side. Again, I like to plug these into the factored function, and when my asymptote is at 0, I just like to carry the sign. To see 3 plus 2, I'm going to have a 5 over 3 plus 4 is a 7, and that's going to be multiplied by 3 minus 2 is 1. So I can see that's going to be at 5/7, which is a positive number. So I know when I'm over here at 3, I'm going to be up at 5/7. Well, that's a bit more than a half. So because I know I can't cross that x-axis again, this dot is the only one that can. It's going to go up, and it's going to get snug as a bug in a rug down to the horizontal asymptote. Next thing I would do is I would come out to 1, 2, 3, 4, 5. I would plug a negative 5 in there. Again, I don't like to think too hard. I like to plug into my factored function and carry the sign. So I'd have negative 5 plus 2. That's going to give me negative 3 over negative 5 plus 4. That gives me a negative 1. And negative 5 minus 2 is a negative 7. Well, that's going to give me negative 3 over positive 7. So that gives me negative 3/7, just about a half. So when I come over 1, 2, 3, 4, negative 5, I got to go down underneath. Again, this is an enormous piece of information. I'll never cross that x-axis again, so I know I got to stay under it here, and I got to go down here. Fun part is in the middle. Well, the left side here, from my x-intercept to my y, I know it can't curl and go back up. It actually has to curl and go down because I can't cross that x-axis again. So the only other thing is I need to figure out, is this a bouncer? Which I know it's not a bouncer because that's a single root happening up there. Remember, if it was something squared, it would be a bouncer and it would turn and go back down. But this is a single one, so it's going to have to go up. So a lot of that graph stuff that we learned on polynomials, that's going to play into these as well. And if you don't like that, then you pick 1, 2, you're going to put negative 3 in there, and you're going to find a point. So you'd have negative 3 plus 2, that's going to give me negative 1, over negative 3 plus 4, that gives me a positive 1. Negative 3 minus 2, that gives me a negative 5. That's going to give me negative 1 over negative 5. That's going to give me positive 1/5. Just like I said, and it's going up. My graph is off. It actually comes over faster and then goes up. But like I said, it's about the shape that you're getting in the appropriate spots. So if I check this on our graphing calculator, here it is, and I can see, you can visibly see the horizontal asymptote at 0, a vertical at negative 4, and a vertical at 2. And I think we have one more problem to nail out. I'm sure 99.9% of the population is up to speed, but number 5 is a tough little bugger. Okay? When I check this thing out, I can see the denominator does not factor. When I take my denominator, x squared plus 1, I set it equal to 0. I get x squared equals negative 1. When I square that, I get x equaling an imaginary number. We don't have imaginary vertical asymptotes, therefore we have none here. We have no vertical asymptotes in this problem. It's possible. Horizontal asymptote, I can see the degree of the numerator is 0. The degree of the denominator is 2. That means the numerator is smaller than the denominator, so I have to have a horizontal asymptote at y equals 0, which I will plot. And again, that dirty little squirrel's in the wrong spot again. And I'll just move the whole graph. That works too. And from there, next thing I'm going to do is I'm going to look for my y-intercept, because that's just plugging a 0 in for x. And when I put a 0 in for x, that x squared is gone. I get 5 over 1, so that's 0, comma 5. And that's 1, 2, 3, 4, 5. And x-intercepts, well, hey, there's no way when I have 5 over x squared plus 1, there's no way to get that numerator equal to 0. Therefore, there will be no x-intercepts either. So I'm going to say none there because it takes a 0 up here to make a fraction equal 0, and that's impossible. 5 can never equal 0. So now what we have to do is we have to find some additional points. Here's the fun part. So I got an x, I got a y, and what I'm going to do is I'm going to plug in a positive 1. Well, that's not going to be too bad because 1 squared, it's going to give me a 5 over 2, right? That's like 2.5. So I'm going to go over there, 2.5. Well, I can see, let's plug a 2 in there. Well, when I plug a 2 in there, I'm going to have 5 over 5, or 1. I'm going to go over 2, and it's 1. And you see how that little bugger is coming down to the x-axis? Because it's going to, remember your horizontal asymptotes, they're going to be like magnets. They suck the graph right down to it. Well, let's see what's happening on the negative side. Well, if I put a negative 1 in for x, that's going to give me 2 in the denominator. So that gives me another 5 over 2, and it's positive. So I'm going to go negative 1. I'm going to come up here to that 2.5. Well, what the heck's happening here at negative 2? Well, when I take negative 2 and I square it, I get 4 plus 1 is 5. I get a 5 over 5. That's a 1. That's over here at negative 2, comma 1. And what's happening is our graph peaked out. It actually has a maximum up here, and then it's going to come back down, and it's going to flatten out. And this one's going to flatten out on the other side. It's very symmetrical across the y-axis. And it's a hard one because there's no vertical asymptotes, and this one you have to plot a few points to get them. Again, let's check this against the graphing calculator for our last graph. And I can see that that little bugger comes right down to the x-axis, spikes up to 5, and it comes right back down. So, last thing we have is our last page here. This is just a page you have to memorize, guys. Sorry about that, but you just got to remember, how do you find vertical asymptotes? You find vertical asymptotes by basically factoring the denominator, setting each factor equal to 0. Any x value that results in a 0 in the denominator is a vertical asymptote. Okay? Now we have two different kinds of horizontal asymptotes. Okay? If the degree of the numerator equals the degree of the denominator, then our vertical asymptote, again, is going to be y equals the lead coefficient of numerator divided by the lead coefficient of denominator. Okay? Now remember, lead coefficient is not the number that is written first. It is the number that is attached to the largest power of x in both top and bottom. And you just set them up as a ratio, and y equals whatever that ratio equals, that's your horizontal asymptote. However, if the degree of the numerator is less than the degree of the denominator, if that's true, we have no math to do. Horizontal asymptote will always be y equals 0. And coming up, we might even find out about slant asymptotes. So we can also see, I won't even go there. We will have some that don't have any horizontal asymptotes, but that's another day. Hopefully you understand all this. Any questions? I'll be posting these notes actually written out online at the same way, so you can look at the note packet or watch the phenomenal video again. Have a great weekend, or a good day, and don't forget your your quiz on Friday covering graphs. You will be expected to graph 3 different rational functions, and you need to know these rules for your horizontal asymptotes. See you later. Bye.